let's go over the basic strategy of dealing with integrals of the following form, where you have sine to some power, cosine to some power, dx. So a and b are a couple of whole numbers, and the strategy is going to depend on which a and b we actually have there. But the basic idea, for example, let's say we have sine to the 7th x cosine squared x dx. The basic idea is that if one of these guys is odd, like in this case 7 being odd, means that we can pull all of them but one away into, and think about it as something squared to a power. So we have a lone sine, and then we have 3 sine squareds, and then we have our cosine squared. Now, having broken it up like this, we can now rewrite all this stuff just in terms of cosine. So the sine squared is 1 minus the cosine squared. And having done this, we're in a great position to just do a u substitution. We'll make u be the cosine, and the du is going to be minus the sine. I shouldn't have that dx there. So, so this part is minus my du. So if I put that stuff together, let's do it up here, what I have is the integral of, let's add 1 minus my u squared cubed, that's this thing, times u squared, times this part, which is minus du. And that's what I have, and this is a straightforward integral that we could totally do. So you have to actually just multiply it out, and then use the power rule for antiderivatives, and then substitute back in u as the cosine at the end. Right. So it's a little bit of a few steps to do, but that's just fine. So that's the strategy for an odd and an even. I mean, you can always do this basic strategy. If I were to change the numbers a little bit, you can see the same pattern will work. Like, for example, if I have this one doesn't matter, it could be 7 as well, but as long as one of them is odd, maybe if this one is 11, using this one being the odd one, this is a 7 it's supposed to be, then I could use the same strategy with this guy, breaking it up as a single sine and a sine squared to the 5th, and then taking this sine squared and rewriting all this stuff in terms of cosine. Again, making the substitution u as the cosine will put me in good shape to work out that integral. I could do it the other way as well, so this is kind of one direction, but another direction would be, because I have this odd number 7 over here, I can make it as 1 plus 6, and the 6 other ones convert to sines. So I could write this as 11 sines of x. I have cosine squared x cubed and one more cosine. And this cosine squared I can rewrite as 1 minus sine squared. And now I can get away with the exact same strategy, making u the sine of x, du is the cosine, and I have u to the 11th, 1 minus u squared cubed, du. And we're just often running with a u substitution there, just like before. U to the 11th, 1 minus u squared cubed du. We know how to do that integration. Okay, so this strategy is just fine for dealing with one or the other odd. So A or B odd. Then we can do this kind of strategy. What if neither one of them is odd?